now left with the last part of this exercise, which is trying to assess whether our algorithm and our implementation are correct. So we tried just the code once to make sure that it was actually not, going out of array boundaries and stuff like that. Well, this is good, but this is by no means, an exhaustive testing that we did. So now we're going to go back in test.c, and we're going to try to test more thoroughly our code. So one thing we can do is actually to take all possible orders of value in an array of 3 elements. And for each possible ordering of 3 values, we are going to try to sort our array. So this is going to give us an opportunity to declare an array named myTestArray. And we are going to create this as a multi-dimensional array, a 2-dimensional array. So we chose that we would deal with arrays of 3 elements, okay, just for testing purpose. So we are going to have 3 columns in that matrix. How many lines do we have? Well, with 3 elements, we are going to have 6 possible ordering of the same 3 element in an array. So we are going to have 6 rows. So this is what this myTestArray variable represents, a matrix of 6 different test arrays, which we are going to feed to our int-array sort function. So now we are going to initialize the structure. So I'm going to start by, I'm going to take value 1, 2, 3. Really, the values that I take do not matter as long as they're all different and we can order them in ascending order. So I'm going to take 1, 2, 3 for a starter. And this is going to be my first test array. My second test array would be 1, 3, 2. And I'm going to keep going like that. So this is my first and second row of this matrix. Let me attack the next one. I'm going to do 2, 1, 3. Then we're going to do 2, 3, 1. And I'm going to align all of this so that it's a little bit more readable. Okay. And I did here an extra closing brace which is not warranted. And we're going to do now 3, 1, 2. And I'm going to do 3, 2. Oops. Yeah, that's it. That's the last one missing. 3, 2, 1. And we have now our initializer for this matrix. Okay, we declare, we initialize it. And now we are going to test all of those arrays in our sort function. Okay, so to do so, we're going to have a loop for int, let's call it n. I'm using here my habits in C++. For n equals 0, n lesser strict than 6, n plus plus. And to make things better, I should declare the 6 magic value as a constant, but we'll come back onto that later. So I'm going to test my 6 arrays. Okay, I'm going to printf on the screen testing array number %d, so that I know which array I'm actually currently testing. The %d will be the value of n, and then I can do something such as printf original array equal, and I'm going to display now the content of the original array by calling int array display my test array. How do I specify that I want to display the first test array? Well, I just specify a row index by n without specifying a column index. So my test array, what is the size of this array? 3. I display the original array. Int array sort my test array, test parole array n, comma 3. The size of an individual test array is still 3. And then I'm going to display printf sorted array. I'm going to align this right with, actually I can do it like this, with a tabulation. That would be a little cleaner. I'm putting a tabulation, and I'm going to display after that int array display display my test array. Once again, the same row, and the size is 3. So let's see how that would work in practice. Okay, I'm going to save this file. We're going to go back to Conqueror, and we're going to first recompile this code. It compiles okay, then we're going to execute it. So once again, these are my previous tests. Okay, enter values 8, 9, 8, 7, 1, 2, 3, 6, 5, 4. This is my test. There's a little bit more output here that's happening, so we're going to scroll back up and catch up with what happened. That was my first attempt at displaying the array that I scanned. Then I sorted this array that I scanned and I displayed it. This is still working. Then I'm testing array 0. You can see here array 0 is 1, 2, 3. That's what we wanted. Sorted version is 1, 2, 3. No problem. 1, 3, 2, 1, 2, 3. 2, 1, 3, 1, 2, 3. 2, 3, 1, 1, 2, 3. 3, 1, 2, 1, 2, 3. 3, 2, 1, 1, 2, 3. So apparently our program is working, and we tested it exhaustively on all the permutation possible on an array of 3 distinct elements, and it appears to be working correctly.